Welcome back everyone to another video here on the Unknown Code YouTube channel. As always, I am Ethan. Today we are coming back with another LeetCode video. This time we're working on problem 26, remove duplicates from a sorted array. This is a very popular problem which states given an integer array nums sorted in non-decreasing order. In this statement, non-decreasing order is definitely going to come back a little bit and be important whenever we try to solve this. And what we want to go ahead and do is remove the duplicates in place. Again, in place is significant once again because this means that they do not want us creating a new array and putting things inside that new array. They want us to go ahead and do this inside of the original array such that each unique element appears only once. And again, something else that's going to be important, unlike one of the previous ones that we did, that the order doesn't matter. This time around, they want the relative order to be kept the same. So that means if 1 was in the first index and then there's some duplicates after that, 1 should still be in the same index. It doesn't want things flipped around. And then it's also going to want us to go ahead and return the number of unique elements inside of nums. And they're going to have us call that k in this case. So below we're going to see that, hey, it's going to be talking about the number k. In this case, that's just going to be the unique number of elements that we find inside of our algorithm. And then below it kind of gives us some more details about the problem. So consider the number of unique elements of nums. So that's just the array to be k. So like I was saying, basically the unique number of elements is going to be called k. And to be accepted for this problem, we're going to do the following. So we're going to have to go ahead and change the array called nums. And this would mean whenever it said in place, we have to actually change the array called nums. We can't make a new array. And what we're going to be looking for is the first k elements to be the unique elements. And then everything else after that does not matter. And then like it said above, we have to keep these in relative order. So for example, if we find 5 elements that are unique, then the first 5 indexes of our nums array are going to return those 5 unique elements in the correct ordering. Something else to keep in mind is that since we are going to be doing things in place, here you can see that they have some special judge, and all this special judge is going to do is loop through all of our elements and then make sure that the numbers are matching what they expect. And to be able to pass this, you're going to have to actually be able to pass this one as well as the number of k. And it's going to use the number k, you can kind of see here, to loop through those first k elements. It's going to be important that we return the correct number of unique items here. So let's go ahead and take a look at our examples down below. So for our example number 1, we're going to have some array called nums with 1, 1, and 2 inside of it. And whenever we're looking at this array 1, 1, 2, and what our output's going to look like, we want to get rid of the duplicates. So we're going to bring down the first instance of 1. We're going to ignore the second instance of 1. And then we're going to bring down the second instance of 2. In this case, this is going to be end. The last element doesn't matter. So it can just be an underscore. And the number of unique elements is going to be equal to 2. So what's going to happen is we're going to return this number 2. And then the custom judge is going to look at the first 2 elements of our output, which is still just nums, which will be 1, 2, and then pass. Let's go ahead and take a look at our second example. Example 2. In this case, our nums is going to be an array with 0, 0, 1, 1, 1, 2, 2, 3, 3, and 4. This is going to be a little bit more complicated example. Our output will still be equal to nums, except nums is going to be actually modified. So in our case, the first one will copy over a 0, and we'll skip a 0, we'll copy over a 1, and then skip 2 ones, we'll copy over a 2, skip a 2, we'll copy over a 3, skip the next 3, we'll copy over 4, and then this is going to leave us with 5 unique values. And then the rest of these are all going to be underscores or zeros, so it doesn't matter what the number is. So here, unique would equal 5, and our custom test judge would go through and look at 0, 1, 2, 3, 4. Make sure all of these are unique in the correct numbers, then it'll determine whether we should pass or not. Let's go back up and take a look at our constraints and try to figure out how we may be able to solve this problem with the knowledge that we've gathered so far. So taking a look at our constraints, there's nothing really too crazy here to look at. Firstly, we just have 1 is less than or equal to nums.length is less than or equal to 3 times 4 to the 10. So basically just saying the length of array is between 1 and 3000. Nothing crazy on that one. The next constraint says that the actual values stored inside the array are going to be between -100 and 100. So again, nothing super crazy here that we need to be concerned about. The final really useful piece of information is that nums is going to be sorted in non-decreasing order. This means that the smaller numbers are going to be in front and the larger numbers are going to be in the end, which is going to be actually really helpful for us to go ahead and solve this problem. So far, the biggest thing to note when trying to solve this problem is that the array nums is going to start out already sorted smallest to largest for us. This is significant because any duplicate numbers we find will actually be stored next to one another inside of the array, meaning we can basically count how many duplicate numbers we found and start placing non-duplicate numbers starting at the very beginning of that string of duplicates. Also, the length of the array will always be at least 1. So this means that no matter what, we'll always find at least one unique value, because if it's only 1, there can't be any duplicates. So that's also something to be thinking about as well. So using this knowledge, just go ahead and hop down below and start thinking about some pseudocode and think of how this will actually work. So for our pseudocode, the first thing that I want to think about is that last fact that we talked about, saying that no matter what, there's always going to be at least one unique element. So I want to go ahead and start out by noting that the number of uniques is going to be at least 1. And I'm going to add parentheses here because I'm going to actually use this unique kind of like as a variable. Then we want to say that for each value inside of nums, what we want to do is say while the value at the current index is not equal to the value at the next index. If this is the case, then that means that they are not duplicates. So what we want to do is set the value of nums to unique equal to the value at the next index. Since we found another unique, we want to go ahead and increment the number of uniques that we found. And once we've gone all the way through each value and found each unique, we want to go ahead and return that number of uniques. So this is what the pseudocode is looking like. Let's go ahead and take a look at our bigger example that we have a bigger data set to show you all how this is going to work out. So this is going to be a little bit of a bigger example. So I'm going to try to fit it all in here. I may need to kind of break it up a little bit, but we're going to start with an example with our nums array equal to 0, 0, 1, 1, 1, 2, 2, 3, 3, and 4. I'm going to try my best to keep track of everything going on here. So the first thing we wanted to go ahead and do here is say iteration 0. In an iteration 0, unique will be equal to 1 because that's our default case. Nums of I will be equal to 0. In this case, that's our current value. And then nums of I plus 1 will also be equal to 0. So we're checking 0 and 1 here. They're equal, meaning they're duplicates. So we're just going to go ahead and continue and move on to the next iteration. So now at iteration 1, our unique is still going to be equal to 1. Our nums of I is going to be equal to 0. And our nums of I plus 1 will be equal to 1. In this case, the value of I and I plus 1 are not equal anymore. Now that we found a new unique value, we want to go ahead and set the nums of index unique equal to this new unique number, which is equal to 1. So nums unique is equal to nums I plus 1 is basically going to say nums of 1 is equal to 1. We need to also go ahead and count up the number of unique. And now our nums array will look like 0, 1, 1, 1, 1, 2, 2, 3, 3, 4. But this is okay because we're only going to read the first k elements. Now let's move on to iteration 2. Here, unique is going to be equal to 2 now. Our nums of I is equal to 1. And nums of I plus 1 is also equal to 1. So here, we're just going to continue the loop. For iteration I equals 3, unique is still equal to 2. Our nums of I is now still going to be equal to 1. Nums of I plus 1 is equal to 1 again. So we just continue. For I equal to 4, our unique is still equal to 2. Nums I is equal to 1. Nums I plus 1 is now equal to 2. We found a new unique. So now we need to go ahead and set our nums of unique equal to nums I plus 1, which is basically setting nums of 2 equal to 2. And finally, we need to go ahead and count up the number of unique. And now our nums is going to look like 0, 1, 2, 1, 1, 2, 2, 3, 3, and 4. Now for iteration equal to 5, our unique is going to be equal to 3. Our nums of I is equal to 2. And our nums of I plus 1 is also equal to 2. In this case, we'll just continue. Iteration I equals 6. Our unique is still equal to 3. Our nums of I is equal to 2. And our nums of I plus 1 is equal to 3. So we found a new unique number again. So now we'll go ahead and set the nums of unique equal to nums of I plus 1, which is basically saying nums 3 equal to 3. And now we need to also count up unique. For iteration 7, our unique is now equal to 4, and our nums of I is equal to 3. Our nums of I plus 1 is equal to 3. So this one, we just continue. Iteration 8, our unique is still equal to 4. Our nums of I is equal to 3. Nums of I plus 1 is equal to 4. So once again, we need to go ahead and set our nums unique equal to nums of I plus 1. We need to go ahead and count up unique. And finally, iteration I equals 9. Our unique is equal to 5. And in this case, our I plus 1 is greater than nums.length, which means our loop is finished. So now we just need to go ahead and return unique, and then the judge will read out the numbers. And at this point, we should be good to go. I know I'm a little bit tight on space here. It is what it is. But let's go ahead and hop into LeetCode and implement this so we can see how this works. Inside of LeetCode, we can go ahead and start. So this is a very, very simple algorithm actually. So we need to go ahead and start with our unique. So we're going to say int unique is equal to 1. Like we mentioned before, we're always going to have at least one unique. Then we can go ahead and start looping through all of our indexes. So let's go ahead and say for int I is equal to 0. I is less than nums.length minus 1 and I plus plus. And the nums.length minus 1 is so we don't go out of bounds. Then we want to check the current value of nums is not equal to the next value of nums. So we'll do that by saying if nums of I is not equal to nums of I plus 1. And in here, if this is the case, we'll go ahead and say nums of unique is equal to nums of I plus 1. And then at the end of this, we want to go ahead and count up our unique. And finally, after all of this loop, we'll go ahead and return our unique. That's it. That's all we have to do. Let's go ahead and submit. Hopefully I didn't typo anything. And we get a run millisecond runtime. It says that there's some 0 milliseconds, but if you try to look at them, they don't actually exist. It beats 99.96%. We could do a little bit better on the space complexity, but it is what it is. I'm not that concerned about it. And that is a very simple solution to remove duplicates from array. As always, I hope you all enjoyed. If you did find some value in this video, please leave a like, comment, subscribe. Everything helps me out here in the YouTube journey. As always, I'm Ethan on LeetCoder. Have a great day, everybody, and see you in the next video.